Okay, welcome, Sarah and Megan and my Lupita or Maria.
Yeah.
Let me share my desktop and I'll talk about the plan for today.
Okay.
Okay, so here's the plan. Let me make sure you can see it. So here's a plan. As always, I'll start out with questions if there's any questions. And the main focus will be your project because your project's due on Sunday, but really your draft is due on Thursday at 8 in the morning, but better to send it in Wednesday so I can get to it faster. And that's a big chunk of the grade. Whereas there is still a chapter to talk about. So we are going to talk about the chapter, but again, questions is good day for questions. We actually kind of have a lot of time. I don't expect this to be as long as a normal webinar. Maybe I'll be wrong, we'll see. Because the material, most people find this a little bit easier, a little less stuff to talk about, but that doesn't mean not important. It's still very important. But it's a lighter week instead of material. And the main reason why it's a lighter week is you have a project due. So it's a heavy work week in terms of work, but in terms of statistics material, it's kind of light. And also you have an exam in another week. So, kind of a 1-2 punch are coming up. So a lot of stuff coming up. So I lighten up a little bit about the new material. So what we'll talk about, though, very important new material, is we'll start with the standard normal distribution. And we've actually seen it before, but we haven't done anything sophisticated at all about it, but it's time. So we're going to be looking at specifically the empirical rule. We're going to be looking at it a little deeper, and then we're going to move on. We're going to look at calculating probabilities and percentiles. So if you want to find out the probability, when we had a uniform distribution, it was just a rectangle base times height, very simple math. Hopefully you thought base times height wasn't too bad. On the other hand, normal distribution is intense, the mathematics. So the good news is that means you don't have to do it. But I do want you to understand the empirical rule. So we'll do a couple special cases, which are pretty simple. And then we're going to move on and we're going to do the intense stuff. So as we saw last week, when you have a continuous distribution, the probability of being between two values is the area under the curve in between those two values. That works great if you have a rectangle, but if you don't, which is most of the time, it doesn't work great, which means you got to trust me and use the calculator that I created, okay, and come up with this probability and realize the calculator is doing the hard math. So, but you have to understand what happened. You don't have to understand the mathematical details, but you have to understand what happened and what it means to find a probability. We'll look at the probabilities and percentiles, and you got to remember what quartiles mean and interquartile range and all that kind of stuff that we had earlier. But now we're going to be doing it for the normal distribution. Then we'll get into the general normal distribution. So that is going to allow for any mean and any standard deviation, basically, and work on that. And that's where we truly let the calculator do the magic. So we're going to let the calculator do the magic and find probabilities, find percentiles, and do those calculations. Then we'll have some applications. Okay. Unfortunately, you really won't completely understand the purpose of all this until next week. And then from next week on, you'll understand, hopefully, that the normal distribution is everything. Okay, it turns out the world is normal. which is good. I think that's why they call it the word normal, is because it is what describes everything. So anytime you do a sample with a large enough sample size, whether you're doing a yes/no question and whether you're doing a quantitative question, you're going to end up with a normal distribution that you have to calculate. Okay, and it just works that way. It's just beautiful. It always works that way, which means you only need one calculator for most things you do. It's kind of nice. So that is the plan today. So let me ask you any questions. And again, that could be about the project, could be about homework that you've been working on. It could be about the exam coming up.
Did you state APA or MLA format for the essay?
Okay, so here's the deal. So I need to be very honest. I'm a math instructor. So all I care about is just tell me where you found it. You know what I mean?
Okay.
The last thing I'm going to do, I don't even, honestly, don't laugh at me too much, but I actually don't even know the difference between those two things. I've heard of them.
The cited works is a little bit different. It's like works cited or references, or it's like just kind of, yeah.
Yeah. If you use the internet, paste the web link. That works good enough for me.
Okay, great.
Yeah. To me, the focus of this project, and hopefully you understand, the focus of this project is use the proper vocabulary of statistics and to make sure that you understand all the little pieces that we've done when it comes to the mean, the median, the standard deviation. The standard deviation, I can say it twice because it's that important. The first quartile, the third quartile, the interquartile range, the maximum, the minimum, and then the important plots that you must have, and that is the box plot, the stem and leaf, and the histogram. And what I care about is that you truly show that you understand how they can be used. Okay, not the formulas. Don't give me any formulas, but how is the client going to make a decision after looking, or what decision might the client make after looking at, say, the median, or after looking at the box plot and the box in the box plot? Does that make sense?
Yeah.
So that's the focus. You know, obviously it should be readable. So if your English is so bad I can't even read what you're writing, that's not good at all. But things like MLA, I don't know, whatever. I've heard those letters. Don't ask me to do it. I could look it up on the internet and then probably make it work right, but that's not my expertise. And that's not what I'm picky about. But I am picky about, say, use the word mean instead of average. Does that make sense? So those are the kind of things. And that you're going to use the empirical rule, which I'm going to refresh again. Or you're not going to use the empirical rule because you've looked at your histogram and realized you can't. So you got to use Chebyshev's theorem. So those are the kind of things that I want to see. Hopefully that makes sense. So yes, make sure that's your focus of the paper, because this is a math class. But good question. Very good question. Okay, so again, it should be very readable. Don't make it look like a text. All right, you don't know how many. I'll tell you the number one, I don't know if you know, what do you think the number one modern grammatical mistake people make now? And I've been doing these projects for a while. It didn't used to be a problem, and now it is. Anyone know? By far.
Is not it knowing there and there?
No, that one's not too bad. I see it sometimes. Not knowing how to use the apostrophe. Oh. And I think that's because when you text, you never use apostrophes. But I've noticed that one. That's the biggie. So might be because spell check doesn't look at it, or I don't know. But that's the biggest grammar mistake I see. So I might take off 1 point total for all the grammar errors you can make in the whole paper. But on the other hand, if you don't understand what the standard deviation, it'll be ugly for you. Does that make sense? Any other questions?
Do we have to have the rough draft in by Thursday?
Yeah, so if you want me to look at your rough draft, 8 in the morning Thursday.
Does it have to, do we have to turn it in for credit?
It's not for credit,
Okay.
but let me be honest. Those who don't turn it in almost never get A's. Not because I'm mean to you and I'm angry that you didn't turn it in, but the people who turn it in, like on Wednesday especially, I look at all their mistakes. I write down a whole long list, like of 10 different things to change, and they fix all those 10 things. And all those points I would have taken off because of those 10 mistakes got fixed. Does that make sense?
Mm-hmm.
But if you don't send me a rough draft, those mistakes, you're going to lose points on them. Does that make sense?
Yes.
Because you won't even know about them. You know, not because I'm evil or anything, but I want to help you, and this is the way I help you. And
Okay.
so Thursday at 8 in the morning is a cutoff. After 8 in the morning, I won't accept it. But Thursday is 8 in the morning is a cutoff time. So that is important, but it's a first come, first read basis. So if you send it at 7:59 in the morning on Thursday, it might be a while before I get back to you because I'm going to read everyone else's first. Does that make sense?
Yes.
And they're often like, these could be 10 pages. It takes me a long time to read them and then type out all the different things that can be fixed. And so that, you know, it takes me a long time. So if you're last, it might be a while before you get my feedback, if that makes sense. So that's the piece on that, but I'll always take questions throughout, you know, all the way up until, you know, Sunday night. Of course, if you send a question at 10 o'clock at night on Sunday, do you know when you'll get an answer? Probably 5:30 in the morning on Monday, because that's my sleep schedule. I'll be asleep. So don't expect a late night answer on Sunday night because I'll be asleep, and I do not answer questions in my sleep. So just a note. Other questions? Other questions?
Will the exam be timed, and how many questions can we expect?
Yeah, the exam is timed. So you get 2 hours for the exam.
Okay.
Unless you have a disability and, you know, because of your disability, the Disability Resource Center said you get extra time, and then I give whatever they tell me if there's a disability. But if there's no disability, then it's a 2-hour exam.
Okay.
The how many questions is honestly a useless question. Nothing about you,
Mm-hmm.
because some of the questions might have an A, B, C, D, and E.
Oh, okay.
And some questions are true, false.
Okay.
So some take 10 seconds,
Mm-hmm.
if you understand it, and some take 10 minutes.
Mm-hmm.
So the number of questions is not very relevant,
Mm-hmm.
because, and in fact, before COVID, there were a lot fewer questions. And it has to do with now that COVID's on, it's all online on a computer with Canvas.
Yeah.
And Canvas works better on the true false if they're individual. And I used to have question number 1, answer the following true or false, and there'd be an A, B, C, D, E, F, G, and H. Does that make sense?
Yeah.
Now it's 1, 2, 3, 4, 5, 6, and 7. So the number of questions is really complicated.
Okay.
You know, but that doesn't make the test harder. It's a hard answer. It's a hard
Okay.
one to answer. I will let you know next week, and this is very important, Tuesday at noon next week. That's a good day to be there, because next week, one thing, we're doing the central limit theorem, which is really important, but then we're also going to be doing a review for the exam.
Oh, okay.
So next week is the week to review the exam. It's a big week, and that webinar will go longer probably, where this one will go probably shorter, unless there's a huge number of questions today. But that's why I'm specifically wanting more questions, because I don't have that much to say today. So next week I'll be going over, I'll say problem number 1, this is what it looks like. Problem number 2, this is what it looks like. I'm not going to like read exactly word for word, but I'm going to let you know, problem number 4, you're going to have to compute the expected value. You're going to have to explain, interpret the expected, that kind of thing. Does that make sense?
Yes.
Yeah. So that's the kind of stuff. I'm not going to read word for word the problem though.
Okay.
But definitely a good day to be there and make sure that you have time to study in between. So Tuesday at noon will be the webinar, And then your first chance is Thursday evening, I believe. So that gives you some time if you're taking it Thursday. You could also take it Saturday or Sunday of the following week. So there's 3 choices. Okay. So yeah, but the exam's important. It's a big piece of the grade. So it's one of those you want to practice. So plan on that.
Okay.
Okay. And if you have time, you could even do some of that this week,
Mhm.
Could always go back to the old homeworks.
Yeah.
And the discussion. The discussions are probably the most important things. Discussion assignments. If that makes sense. Okay, other questions? Okay, if there aren't any questions, let me talk about the new material. And I'm going to ask questions for you guys too to see if you remember. So let me ask you, see if you remember, what is the shape of the standard normal, of the normal distribution in a few words? Maybe one word even.
A bell?
It's a bell shape. Okay. So the shape of a normal distribution is a bell shape. And as I mentioned, today is very hard to convince you how important it is. That happens next week. So I can't do all of statistics in 1 week. Next week is the big theorem that says the normal distribution is everything. Okay. And we'll understand why, but not today. So right now, just kind of wing it and realize that it is important, and trust me, and you'll find out why next week. Sound good? Okay, let me pull out a picture of the standard normal distribution that we've had before. Okay, I don't know if it was exactly the same style of picture that I pulled off the internet. Okay, where have you seen 68, 95, 99.7? What do we call that? Do you remember? Start with an E. It's important because it's part of your project, or it could be. I don't
Is
see
that
everyone.
expected values?
Not
No.
quite. It came before last week. Might be why you're having trouble, because it was so long ago. It was week 1, I think, in at least chapter 2. Okay, that was the empirical rule. Do you remember the empirical rule? That said that if you go within 1 standard deviation, that is going to take approximately 68% of the data. Do you remember that happening? If you go 2 standard deviations, that will approximately make up 95% of the data. Okay. And to let you know, 2 standard deviations is the most important. And we'll understand why in 2 weeks. We're not quite there yet, but in 2 weeks, we'll talk about why that 95% is so important. It's what most people use, most researchers and most articles will deal with the 95%. Okay, but there are the other ones that is important is that if you go 3 standard deviations from the mean, in this case with the standard normal distribution, the mean is just 0, then you're going to get 99.7% of the data. Notice 3 standard deviations is almost all of it. Do you agree? If you cover 99%, that's way, way much. Okay. If you just gave birth to a baby that is more than 3 standard deviations from the mean in weight on the heavy side, what does that tell you about that baby?
It's a healthy baby.
It's healthy, but you're not healthy because you're in such horrible pain because you had to push that sucker out if you're a woman. If you're a man, you got to deal with with the women who did it. But yeah, it's a healthy baby, but it is a gigantic baby. Does that make sense? Okay, so I just want to remind you what these mean. Whereas 2 standard deviations is still really big. That's still an outlier if it's past 2. Because remember, 95% is most of the data. Okay, that's a big, big chunk. But 99.7 is so much, it's like shocking to see anything more. Any questions on that? Okay. Oh, I forgot to tell you, I was a little worried about whether this webinar was going to happen. Do you know why?
Power outage.
Worse. Earthquake.
Oh, wow.
Had one yesterday and today in the morning. So I'm not sure if anyone of you from Tahoe, but it was right in the middle of Lake Tahoe, actually. So fortunately, we didn't have that problem. But again, if you look at earthquake, the probability of 2 earthquakes happening within 2 days is pretty small. And scary too, by the way. Just let you know. So fortunately, the world didn't fall apart, and it was a small earthquake, but that kind of stuff happens. So I should warn you that if ever I don't show up, that there's a good chance that like there was an earthquake or something like that took out everything. Hopefully not. So I was a little worried when I woke up this morning. It's like, is internet going to work? And it did, fortunately. So here we have this big standard normal distribution. Standard normal, again, the mean is 0 and the standard deviation is 1. Any questions on the shape of this? Okay, what I'm going to do now, I'm going to make this smaller, believe it or not, because we're going to do stuff with it. And I want to copy it and paste it. There. Is now let's find some probabilities and do stuff with the normal distribution. Okay, so let's start out with the first question. And that is, suppose that Z follows the standard normal distribution. Use the empirical rule for the following. In other words, use the picture I just showed you. That is the empirical rule. And in fact, I'm going to pop the picture again. So the hint is this is very, very easy. Find the probability that Z is between -1 and 1. Let's see if you can put in the chat box what that probability would be.
8%.
Put in the chat box, huh? So what's the probability that Z is between -1 and 1? And the idea is it's just staring at you in the face. Yeah.
68%.
68%. It's better, right? Good. I like what Chan Mary said. It's 0.68 is a better way of writing a probability.
Okay.
68% is really important for using stuff, but the word probability is a number between 0 and 1, right? But I'll take 60. I would never take off points for 68%. But if you're going to put it, if you were to put 68 in your calculator for P, the probability, it's going to have all kinds of problems. So that's why I'm warning you about the 0.68, that when you pop it into the calculator, you need to put it as a decimal. Is that clear?
Yeah.
Okay. And that's not just my calculator being picky. All calculators do that. So that's standard for calculators. Any questions on that? Okay. And that is, so I'm going to draw a little bit. This is an easy drawing. Hopefully this will work. The probability is the area between -1 and 1. Okay, because that's what the definition of probability is. Any questions on the picture? Okay, now let's do part B. Oops. Part B, let me, let's see if it'll get rid of it. No, it didn't get rid of it. Let's try again. Annotate, clear. Okay, so now let's do another one of these. And this one's harder. Okay, but it's still gonna have the same picture. Find the probability that Z is less than 3. Any questions on the question? So note that Z is less than 3 is all of this stuff here. And it's not letting me do the last one, but that's good enough. Any questions on the z is less than 3? Okay, actually, I do need to write a little more. Will let me? Drawing is always a pain on the computer. Try it one more time. Yeah, there we go. I want to draw that last little bit in there. All right, well, how do we find the probability that z is less than 3? Any suggestions? This is a little bit of geometry. Whoops. Any ideas? Okay, so the idea here is we know what it is between -3 and 3. Any questions on that? Now, -3 to 3 is not all of it. There's a little bit more. There's the part between -infinity and -3. So if we add that part between -infinity to -3 plus -3 to 3, that'll give you the stuff less than 3. Any questions on that kind of description there? So now I might lose, I think I'm going to lose my annotation. Let's see if that worked. Nope, didn't work. It's doing some weird things. Yeah, I got to kill the annotation, but that's okay. Okay. So what I need to do is I need to find that probability. Well, what's the probability between -3 and 3?
Maybe 9.7.
Yeah. So I'm going to take this 99.7. So I can say the probability that z is less than -3 is equal to the probability that z is between -3 and 3, less than 3, sorry. So -3 is less than z is less than 3, plus the probability that z is less than -3. Any questions on that idea? So that first part is 99, but it's not 99.7, it's 0.997. Remember, you want to write decimals, especially when you're doing math. When you're doing additions or multiplications and things like that, it's definitely better to use decimals. Okay, then what about the probability that z is less than -3? This part over here. How do we find that? Okay, and the idea here is use symmetry. We know that this piece to the left of -3 and this piece to the right of 3 are the same area. Do you agree? All right, so if I add those together, then I get everything except between -3 and 3. So I can use the rule of complements to figure out what those are. Now, if I get both of those, that's not what I want. I only want one of those. So if I got twice as much, how do I get exactly as much? What do I have to do? Any thoughts?
Divide.
Yeah, we want to divide by 2. So what I do now is I go plus, and now I'm going to take the 1 minus 0.997, because that'll give me the 2 sides divided by 2. Any questions on this calculation? Okay, and again, you can pop that in a calculator, whatever you do, you can do it in your head if you like doing that. So 0.997, and then 1 minus 0.997 is 0.003, divided by 2 is 0.0015, so 85. And there's the probability. Did I lose anyone there? Again, you can use a calculator. Any questions at all on this example? I'm sure you all agree this is a lot more intense than the first one, where you just looked at it and it was 68% or 0.68. All right, let's do the next one. Let's find the probability that z is between -1 and 2. So now it's kind of similar in terms of strategies. Let me draw it. So -1 to 2. Well, -1 to 2 is -1 to 1, and then 1 to 2. So do you agree that what I shaded in is between -1 and 2? Any questions on that? So now we do something very similar. So I'm going to drop the annotation because that's kind of how I have to do it. Sorry about that. Something weird happened. Let me try something. It's doing too big. For some reason, it's capturing more than I want it to capture. I wonder if I can kill it this way. No, it didn't work. Oh, well. I can still make it a little bit smaller at least. Okay, so if I want to go from -1 to 2, then I can do probability that -1 is less than x is less than 2 is equal to the probability that -1 is less than x is less than 1 plus the probability that 1 is less than x is less than 2. Any questions on that?
I'm actually, is X supposed to represent Z in this scenario?
Oh, sorry. Yeah, let me use Z.
Okay, that's
I'm
okay. I
so
just want to
used
make
to
sure I
using X.
understood.
Yeah, I'm so used to using X because that's like the math letter. But you're right, it should be Z. Thanks. Okay. So what's the probability that Z is between -1 and 1? What is that probability? Maybe I'll try and make it bigger. That might help so you can see it. What's the probability that Z is between -1 and 1? And the key is, that's all shown in the picture. That's easy. We already did that one. Yeah, 0.68. Plus. Okay, so now we got to fit in the probability between 1 and 2. Well, if you take the area from -2 to 2 and subtract the area from -1 to 1, you're going to get these two pieces. Well, that's two pieces and we want one of them, so we're going to divide by 2. So I'm going to take 1/2 times, and then I'm going to take the 0.95, because that's the area between -2 and 2, and I'm going to subtract 0.68, because that's the area between -1 and 1. Have I lost anyone on that? Any questions on that? Any questions? Okay, and that is what, 68 plus 130, 113.5 is 81.5. If I did my head right. Just use a calculator. Any questions at all on that idea? Okay. Let's do part D. All right, find a Z such that there's a 2.5% probability of being greater than this value Z. All right, so let me make this bigger so we can see it. Okay, first thing, if there's a 2.5% probability of being greater than a value, is that value far to the left or far to the right? If there's a 2.5% chance of being greater than that value, is it far to the left or far to the right? Yeah, far to the right. So that's the first thing. We know it's going to be a positive number, and that's important to look at. Okay, and the key here is you kind of do what we just did backwards. So there's 2.5% on the right of something. So if you double that, you get 5%. Is that clear to everyone? All right, that's the outside stuff. If there's 5% on the outside, what percent's on the inside? So if there's 5% on the outside, what percent's on the inside? Yeah, 95% or 0.95. Any questions on that idea? All right, well, then you just look at the picture. 95% is in the inside. We know we're on the far right. So what's our number? What's our value of Z? Not 2.5, let me type it all out. So since 2.5% is on the right, 5% is on the outside. So 95% is in the inside. So what value of Z? Now it's Z. Z is not a percent. Z is not going to be one of these kind of numbers. Z is on, this is the Z axis, the horizontal axis. What value of Z is going to get you that 95% area? There's nothing to do but look. So take a look at the picture, and what value of Z will give you the 95%? So look at this picture. It's one of these numbers down here. And
2.
which is, what's that?
2.
2, because 2 is the right-hand side of the 95% interval. So Z is 2. And that's it. Any questions on that? Okay. Now we're going to move on and we're going to do something very different. Okay, at least the way of thinking about it. It's really the same kind of picture. Now we're going to follow a normal distribution with mean 114 and standard deviation 23. Okay. By the way, when you have a picture like this, like the horizontal line, when you had a uniform distribution, it was just y equals a number. Okay, if anyone can guess what the equation is for this graph, I would be very amazed. Any guesses? It's 1 over the square root of 2 pi e to the negative x squared over 2. So if I say it really fast, what does that mean?
We don't need to know it.
Exactly. You don't need to know it. But I figure I should say it so that I can say that I said it. Sound good? So there is a function, there's a lot of math involved, but way too much for this class. Okay. But at least you can do the empirical rule if it's like a nice, between -1 and 1. That's just 68% or 0.68. But now we're going to get into harder things. Okay. So now we're going to say, suppose that x follows a normal distribution with mean 114 and standard deviation 23. Find the probability that x is between 100 and 120. Any questions on the question? All right, so this one, since I told you the equation is really hard, how do you think we're going to do this? Any thoughts? Any guesses?
Calculator.
Exactly. Yeah, you're definitely going to do the calculator, which means I'm going to just write it down on paper because I'm going to leave it and come back. Then you can write it too if you want. So we have 100 less than x less than 120. We have 114 and 23. All right. So I tried to make it easy. I bet I don't have to explain anything, but you could do it given to the calculator. Let's see if you can walk me through it. And I bet you can. If you wrote down all the numbers that I just gave you. Tell me, what calculator do you think is the right calculator to use?
Normal probability.
Yeah. Okay, again, it's in order at which we do things in this class. I tried to make the words as simple as I could. You hit normal probability. Okay, fill in all of the values except one below and hit calculate. Then the last value will be given to you. Okay, do we know the low?
$100.
Yep, 100. Do we know the high?
120.
Yep, 120. Do we know the mean?
114.
Yep. Do we know the standard deviation?
23.
23. Do we know P?
No.
No, we don't. So that's when we leave blank. And we hit, what do you think?
Calculate.
Calculate. Okay. And by the way, this is many more decimals than you would ever want. So I chose not to do any rounding, and that way, however many decimals you need, you have. But, probably I've never seen anyone ask for more than 4 decimal places. So 4 decimal places like that. If you're doing the computer assignment for the chapter problems, 4 decimal places is probably what you want, which is 0.3315. Okay, if you're doing it for like an exam, 2 decimals is just fine. Okay, and the main thing, if you're doing it for your exam, write down what the low 100, high 120, write those down. And let me tell you why you want to write those down, low, high, mean, standard deviation, with kind of those words. Because let's suppose, you did everything perfect and you accidentally wrote 0.53 instead of 0.33. And all you have on your paper or your computer, your answer is 0.53. What do you think I'm going to do?
Mark it as 0.
Yeah, I can't really give you any points. I might give you like sometimes I call it the mercy point. If it's out of 10, I might give you 1 out of 10 just for writing something. But I can't give you any points. Does that make sense?
Yeah.
On the other hand, if you wrote low 100, high 120, mean 114, standard deviation 23, and then you wrote 0.53, then I'll say, you know what? Person knew exactly what was going on, just wrote it down wrong, and you'll probably get 9 out of 10. Do you see the difference?
Yeah.
So big suggestion for taking an exam. That's the reason for showing your work is so that if you make a little tiny mistake like that, then I can give you lots of points. And I want to give you points. If you don't show your work and you make a tiny mistake, which we all do, I make mistakes too, then it's really bad for you. Does that make sense? Because I can't
Okay.
find points to give you, and I want to give you. So that's just a big note when you're writing down your answer on the exam. Make sure that you write down what you put in the calculator, especially if it takes less than 5 seconds to do it. It's worth it. Any questions on that? Okay. And even if you made a mistake and you, I don't know, chose the standard deviation to be 40 because you just didn't read it right or you didn't understand it, at least I can give you points for the low, high, and the mean. Do you see? Even though your P was wrong. Okay, so let's go to the next question. How about the probability that X is greater than 200? So what do you think we do? Are you going to do this by hand?
No, back to the calculator.
Absolutely. Okay. Can this be done by hand?
Don't know.
Not by you. And I don't know if Braulio could even do it by hand. Do you think you could do it by hand, Braulio? Yeah, I could, but I have a little more math, experience even than Braulio. So the point is, don't even think about doing it by hand. And if it was an exam, I couldn't do it by hand because it would take me too long. I could do this by hand. It would take about an hour to get a few decimal places. That's how evil this is. Okay, but if you do it by the calculator, it's not evil at all. So we have X greater than 200, but things get a little bit different now. And this is important to note. So what changes? Do we know the low? If X is greater than 200, do we know the low?
Oh, 200.
200. Do we know the high? What is the high? If X is greater than 200, what is the highest X could be? What's the biggest number bigger than 200? And it's kind of tricky. If I say it, you'll say, of course, but you might come up with it. Give you another couple seconds. Okay, if you don't know, infinity. Don't you agree? Infinity is the biggest number greater than 200. Okay, but infinity, computers can't handle infinity. There's no way to type in, if you type in the letters infinity, that the computer won't see that as a number. So you have to kind of trick the computer. And the way you do it is you look at the number of digits. How many digits do you see?
3.
3. Okay. Add 2 more. How many digits?
5.
5. And put 5 nines. And what that does is it gives you so many standard deviations above the mean. Or not, sorry, not there. Oops. There. It gives you so many standard deviations above the mean that there is basically no significant area to the right of 99,999. Okay. So adding 2 nines is always very safe. 1 9 is pretty safe too, but how long does it take to add 1 more? Okay, you could do 10 nines if you wanted, that'd be fine. But I recommend at least 2 more nines than the number of nines than the number of digits of all the numbers, of the biggest number.
Okay.
Okay, standard deviation, mean and standard deviation, do those change?
No.
What do you think?
No.
No.
Okay, what about P equal? Is that 0.3315?
No,
No.
What should I do with that?
take it out.
Yeah, kill it, make it blank and hit calculate. Okay, notice it's a very small chance, 0.00000923, etc. But that's your answer. Any questions on doing this kind of problem where you got to deal with this infinity and turning it into a bunch of nines? Okay, and that's how you trick the calculator. All right, let's do the next one. How about the probability that x is less than 90? So let's go back to the calculator. What's a low for less than 90?
0.
Can you think of a number less than 0?
Negative. No.
Infinity.
Yeah, negative infinity. So negative and
Yeah.
5 nines will work. Okay. What's the high?
90?
90. Mean and standard deviation are the same. P equals blank. Let me know if you're not understanding any of this pieces. But it's real similar to the last one. But now we have the left-hand side, or the negative infinity instead of infinity, that we have to trick the computer for. And hit calculate. And you get about 15% or so, or 0.15-ish. Any questions?
Mm-mm.
Any questions on this? Just a note, a suggestion, if you're doing the chapter assignments, go 4 decimal places. Because the computer likes 4. Okay. If it's an exam, do whatever you want as long as you do it out, as long as you show your work. But for the computers aren't, you know, they're pickier. So, because it's a computer. So just let you know that 4 decimal places should always work if you did it right. Okay, let's do the next one. Next one's a little interesting one. That's, how do you read this part D? How do you read part D? Just out loud. What does the P stand for?
Probability.
Mhm. X greater than 105. What's this thing?
Between.
Good try, but it's not between. This comes from chapter 3. That's a hint.
I'm looking.
So lots of good reviews. I like reviewing when I can.
Someone said given.
Good, given.
Yep.
Good, given. Okay, so it's the probability that X is greater than 105, given X is less than 125. So to do that, I can use a given formula. And that's the probability that both are true. Now, if X is greater than 105 and X is less than 125, that means 105 is less than X is less than 125. For both of those to be true, it means it's between. And then we divide by the probability that X is less than 125. Any questions on that? Okay, now that I have that, I can go to the calculator twice. Once for the numerator probability and once for the denominator probability. So let's first do the 105 to 125. So low is 105. The high is 125. Same mean and standard deviation. We don't know the P. If I go too fast, let me know. Any questions on that? And I hit calculate. and get about 0.34. I'll go 2 decimal places. Sound good? All right, so that is 0.34. So let's go back, and I can say this is equal to 0.34 divided by, and now I got to find the probability that x is less than 125. So what changes here to be x is less than 125?
The low,
Yeah, the low. And what does the low become?
the negative affinity 9999.
Yeah, negative a bunch of nines. Okay, what else do I have to do?
Or the P.
Clear the
Yeah,
P.
I got to clear the P. And I hit calculate. And I get 0.68. Okay. And I got lucky because I could actually do this in my head. That's about a half. Actually did not plan that. I just got total luck. But you could use a calculator too. Any questions on part D? Okay, let's look at part E. Find, what does IQR stand for? Very important for your projects.
Interquartile range.
Mhm.
Yeah, the interquartile range. Okay, so now, what's the definition of the interquartile range? Who remembers?
It's quartile 3 minus quartile 1.
Yep. Quartile 3, or the third quartile minus the first quartile, Q3 minus Q1. What is Q3 by definition? What does that mean?
75%.
Yeah, it means 75% is less than that number. Does that make sense? We don't know what that number is. That's what we're trying to figure out. So now we go back to our calculator. All right, so what can I put in if I want to find the number such that 75% is less than that number? So what changes here? What am I looking for? The low, the high, the mean, the standard deviation, or P? What am I looking for? Because that's important.
Would it be the low of 25 and the high of 75?
It's a good try. We're just looking at the third quartile. We're not, don't even go to the first quartile yet.
Okay.
We'll get there. Yeah, so the key here is 75 is a percent. It's not an X.
Mm.
It's a probability. So where does that 75 go? What box?
P.
P. But it doesn't go at 75. How does it go?
0.75.
Yeah, 0.75 or 0.75. What's the one that we don't know? Do we know the standard deviation?
Yes.
Do we know the mean?
Yes.
Okay, so it's either going to be the low or the high. 75% is below some number. Okay, so if you're not seeing, let's go back to the picture. So 75% is below some number. So we're over here. We shade in everything to the left. How far left do we go? When I say shade in everything to the left, how far left do you go?
Infinity, negative
Yeah.
infinity.
You go to negative infinity. So that's the low. What we don't
Okay.
know is the high, because that's what we're looking for. We want to say, well, how far right do you have to go so that you've shaded in 75% of the graph? Do you see how that picture works?
Mhm.
So negative 9999, that stays. The high is now the blank. Any questions on that idea? And I hit calculate. And I get about, let me go to the whole number, 130. So that's 130 minus, okay, Q1. What changes with Q1 for the first quartile?
P changes to 0.25.
Yep, P changes to 0.25. What do I leave blank?
The low.
Not the low, because the idea is it's everything to the left of some number is 25% of the data, right?
Then the high.
Yeah, the high. So it's the number we don't know. The to the left means go all the way to negative infinity. Do you see?
Mhm.
But of some number, that's the high, because you're going to the left of something. That means you're the highest. Do you see?
Mhm.
And I hit calculate, and I get about 98. And that's 130 minus 98 is 32. Any questions on that? Okay, the middle 84% of the data is between what two values? How do I do that? Any thoughts? So the middle 84% is between what two values? So the key here is the picture. Okay, so the middle 84%, we're gonna have two values, like somewhere like here and here. Whoops, yeah, here. Do you see that? So it's gonna be that middle area. And I want this value here and this value here. And I know that 84% is in between those two values. So now we're going to do just like what we did before, is we're going to say, well, if 84% is between the two values, how much is to the right of the smaller value? Okay, or if 84% is between, how much is outside? Let's start there. If 84% is between the two values, how much is outside of those values? Yeah, 16. And how did you get 16? Because I'm sure you did it right. So how'd you get the number 16?
100 minus 84.
Yeah, 100% minus 84% is 16%.
What is it?
Okay, so 16% is outside. So if 16% is outside, what percent is to the left?
What?
So it's 8%. Yeah, 8%.
Look on the back of the package.
Just like
to
we
see
did
the
those
how
others
long.
where you had to divide the two pieces by 2 to get one piece. So that's 8%. So now we want to find out what is the 8th percentile. So let's go back and let's get the 8th percentile. What should be 8%?
Did you
Low,
open the
high, mean,
plastic a little
standard
bit?
deviation, or P? What should be 8%?
The P.
The P. Okay, and you don't write 8, you write 0.08 is 8%. Any questions on that? And then again, this is 8% is to the left of a number. So the high is what we don't know. And I calculate. and that's about 82. Okay, so 82 is the left barrier. So it's between 82 and now we need the right barrier. Okay, to get the right barrier, there's a few choices. We could say, well, 8% is to the right. Is that clear? But now the right barrier is the smallest of the right side. So that means we don't know the low. And then the high is 99999. And I calculate and you get about 146. Any questions? Oh, put it in the wrong spot. Let's try again. That's better. Any questions on part F? Okay, how about the z-score for an x value of 117? What do I do? The hint is I don't need the calculator on this one. Who remembers z-score formula? I'll start you off 117. Then what do I do?
Subtract 114.
Yeah. And then divide by
23.
23. Make it bigger so you can see it. Okay, and I'm not going to waste your time putting it in the calculator, but hopefully you know how to put it in the calculator. You do need parentheses around 117 and 114. Okay, so now it's time for an application. The fun little application. This used to be true in terms of the distribution, and I'll explain medically a little why it's not anymore. Okay, suppose the time until you or your wife, if you're male, will give birth is normally distributed with mean 140 days and standard deviation 7 days. Okay. So by the way, do you think the time at which you give birth is normally distributed? From any day if you're pregnant, do you think the time at which you're going to give birth is normally distributed? What do you think? There's not a math question, it's a medical question.
Hopefully no.
Okay, the answer is no, but it used to be. Anyone know why it used to be and it isn't anymore? C-sections.
Mm.
So if we get rid of C-sections and we only do natural births, then actually it is normally distributed. Okay, nowadays things are different. If you go a week after your due date, they're going to pull it out, right? Okay, so interesting things happen because of C-sections. But in terms of natural births, actually, it is normally distributed. It's one of those interesting phenomena. It can be explained biologically with a lot of work and statistically, but I'm not going there because that's too much science and that would take hours. But you can trust me that it's true. What does it mean that the mean is 180 days? Kind of in, not math-wise, what does it mean in kind of naturally? If you were to tell someone, what words did he use if the mean is 140 days? If you're pregnant, what does everyone ask you?
How many months are you? When are you due?
Yeah, exactly. When are you expecting, right? So when are you expecting, that is the mean. Is that clear? So I figured I'd relate this to reality. This is reality. So if someone asks you, when are you expecting? They're asking, what is the mean number of days, okay, or the expected value for your date of delivery. Is that clear? Now, expected value is, we haven't learned it this way, so I can't really say it, the word expected value, but trust me, you still call it expected value. Okay, but it's a mean. Okay, and standard deviation 7 days, which is interesting. A week is actually is right. I looked this up. So a week is the standard deviation for a delivery, given there's no C-sections, given everything's natural. Okay, now comes the interesting fun part. Okay, your boss has just scheduled you or your wife for a business trip to China. Okay, and we're going to assume, because otherwise things are just too hard, that COVID's over. You're vaccinated. You have no concerns about that. Okay, the concern is not COVID. Okay, you or your wife leave today and will return in 135 days. Find the probability that your baby will be born in China. Any questions on the question? Any questions? Okay, the first thing that I want to do, and it's something that we talked about last week, and that is to write down the distribution in symbols. And I'm going to have you do that on the exam, by the way. So here's what we write. The first thing is the distribution. The letter, is it X or is it Z? What do you think? Or U. I'll throw you in there too, just for fun. Is it X, Z, or U? Because those are the 3 things that we've had so far. What do you think? So is it X, Z, or U?
X.
It's X. Okay. U is for uniform, and this is normal because it says normal. Right? It says normally distributed. So it can't be U. Z is for the standard normal. Standard normal means the mean is 1 and the standard deviation. The mean is 0 and the standard deviation is 1. And the mean is 140, standard deviation is 70. So it's not Z. So X is our only hope. Next week, we're going to have X bar, we're going to have sigma, and we're going to have p hat. So we're going to have 3 more of these to throw out. So it is going to get more complicated in terms of trying to figure out which one of these it is. So it's very important to know what variable you're looking at. And we're looking at X in this case. Do you remember the symbol next that I put in? This is what we learned last week when you're doing distribution notation.
Tilde?
Yep, tilde. What's the next thing? What do you think? Used to be U, but it's not going to be U now. What letter do you think we're going to use now for this example?
Y.
Y is a good guess. N. What do you think N stands for? What does N stand for? It's the whole point of the whole chapter.
Number of
Normal?
Normal. Normal. Whereas U stood for uniform. N stands for normal. Okay. We're going to have others, by the way. We're going to have T. We're going to have T. We're going to have something called chi-squared. Okay. Just trust me. We're going to have F. So there's going to be others that come up later in this course. Okay. It's normal. Then I'm going to put the mean. And the mean is 140. Because what you want to do is you want to put the important numbers. And then I'm going to put the standard deviation, which is 7. And that tells the whole story about the distribution. Any questions on that? Okay, so now that we have 147, and we want to find out the probability, okay, that the baby will be born in China. What does it mean for the baby to be born in China? For X, what does that mean X is? What's X? If the baby's born in China, what does that tell you about X? Reading part A. ideas?
Less than 135.
Yeah, less than 135. Okay, so now we can go to our calculator. So less than 135. Where does the 135 go?
High.
Yep, that's the high. 135. What's the low? Any thoughts? There's actually two reasonable answers and they give you the same answer when you're done. If the baby is born in China, what does that mean? You're leaving today. Don't see y'all jumping
Is
in.
it 5?
It's not 5. 5 would be 5 days from today. Well, if the baby is born tomorrow, it's born in China if you're leaving today, right?
1.
1, 0, actually.
0. Okay.
Okay. We'll call being on the plane born in China because it's going to fly to China. Okay. The standard deviation was given. That was 7. The mean was 140. And we want the probability. So what do you think? 24% chance. Would you do this? If you were pregnant?
No.
I wouldn't, okay? Of course, if I were pregnant, there's a bigger problem. But, or if my wife were pregnant, I'd say, don't even think about going to China. Okay? Not with a 24% chance of having it born in China. It has all kinds of issues. Okay, so let's do some more. So notice the probability is about 23% chance. All right, so here's part B. You decide it's too risky, okay? The funny thing is, sometimes I give this every year, and sometimes people say, yeah, I'll go for it. Not a good idea, okay? But you decide it's too risky. You're going to negotiate with your boss. You don't want to lose your job, so you're going to negotiate instead. But you're going to negotiate, and you've decided that, hey, if there's less than a 1% chance, or if there's only a 1% chance, then I'm going to go for it. Does that make sense? Sounds like something you might negotiate. So we want to make sure there's no more than a 1% chance the baby's going to be born in China. What day should you ask for the return date? Any questions on the question? Okay, so now we want a 1% chance. Where does that 1% go?
Probability?
Yep, P. And you write that as 0.01. What is left blank?
High?
The high, because that's our return date. And that's what we're not sure yet. We're going to try and negotiate. The low is still 0. And I hit calculate. So, and you're negotiating. And if you're a good negotiator, I'd round down instead of up on this one. Because you want no more than. No more than, you better round down, because if you round to 124, that's a little bit more than. Does that make sense? So day 123. So ask to return on day what was it? 123. Any questions on part B? All right, now let's read part C. Part C says it's now 138 days later. Okay, so you're back from China, came back at day 123. So there's no problem with that. Okay, but your baby's still not been born. Okay, And I don't know if you're mothers and fathers or not, but if you're due in day 140 and it's 138 days already, you're getting anxious, right? So now the question is, what's the probability the baby will be born within the next 24 hours? Any questions on the question? What kind of problem is this? Yeah, this is, what is it?
Given.
It's a given problem. Yeah, this is a given problem. So we want the probability that it's born in the next 24 hours. Well, to be born in the next 24 hours, that's between day 138 and 139. So 138 is less than X is less than 139. Given, what do we know about X? Could X be 10?
Just over 135.
135? I'm not sure we're getting 135. 135 was in the last question. What's this question say? What is it today?
138, sorry.
Yeah, so X is greater than 138. Okay, it's a given, so we can use the probability formula, and that's the probability to be between 138 and 139 and greater than 138. Do you agree that's the same thing as being between 138 and 139?
Yes.
If I told you that I am older than 50 years old and I'm older than 30 years old, what do you know about me?
You're over 50?
Right. The over 30 didn't help you at all, did it?
No.
And same idea. If you know between 138 and 139 and you know it's more than 138, the more than 138 doesn't help. So that's just going to be the probability of 138 less than X less than 139, because for the and, the second is just kind of redundant. But then we're going to divide by the probability that X is greater than 138. Any questions on that? All right, so now we just calculate it. 138 to 139. So low is 138. High is 139. Same mean and standard deviation. Leave the probability blank. And hit calculate. And you get about 0.056. And now probability that X is greater than 138. So that means 138 to infinity. I know you can't really have a baby after infinity days, but we're going to go there. Okay, and leave the probability blank. And hit calculate. And you get about 0.61. Okay, this one I can't do in my head. Sorry. Maybe you can. If you can, let me know. Or at least it would take me too long to do it in my head. But I can use Google. And you get about 9% chance, 0.09. Any questions on this? Any questions? And the secret word is symmetric, because the normal distribution is symmetric about its mean. So don't forget SYMMETRIC. Symmetric is a secret word. Okay, we have some more time. So I know it's a bit redundant, but I think it's worth it because the normal distribution is a big part of the class. We're going to be using this a lot. So I want to make sure you all get it. All right. So suppose, okay, that the amount of ice cream that you sell each day is normally distributed with mean 950 ounces and standard deviation 120 ounces. Okay. Today isn't really a good day for ice cream. Do you know why? Today and yesterday. It was just super cold. If you're in Tahoe, you know what I'm talking about. It was a cold. Today, yesterday, it was so cold. Okay, unless you need that to like calm your spirits because of the earthquake. But we're going to sell ice cream anyway. Okay, so the first thing, let's do the following. X tilde n. And it's normally distributed. The mean is 950. The standard deviation is 120. And it's just that. Any questions on that? So if I ask you to write down the distribution, that's what I'm asking, to write that. Okay, so we've got that. So now we want the probability that you're going to sell between 900 and 1,000 ounces. So 900, 1,000, let me write these down so I don't forget. 900, 1,000, and 950, 120. So I go to my calculator. What's the low?
900,
What's the high?
1000,
What's the mean?
950,
And the standard deviation?
120.
And the P is what we want. So we leave that one blank and you calculate. 32% chance. Any questions on part A? Okay. I want to mention, even though I'm spending a lot of time on this, most people don't find this that hard, but it's that important. So it's worth doing and, you know, kind of torturing you by doing it more than you want to see me do it because it's boring. But I'll let you know this is important stuff. Okay. In the morning, you took stock of your supplies and noticed that you have 1,100 ounces of ice cream in your store. What's the probability that you're going to run out by the end of the day? Okay. What does it mean to run out?
To sell all of it.
Yeah, going to sell all of it. So in particular, what do you know about the demand?
Demand is greater than supply.
Yeah, the demand is greater than 1,100. So I can just go to my calculator and I want greater than 1,100. So low is 1,100. The high is
9999.
more nines because remember there's four
Nine.
digits. So go four nines and then add a couple more.
Got it.
Okay. Always add two more nines than the number of digits of the biggest number you see. Same mean, same standard deviation. And hit calculate. So about 11% chance that you'll run out. Okay. And again, depending on your store, you have to decide whether that's worth it or not. So about an 11% chance. Okay, if you want to be 99% certain that you're not going to run out, how much do you have to stock? So where does the 99% go?
Probability.
Mm-hmm. So 0.99. Okay, that you're not going to run out. If you're not going to run out, what's the lowest demand that could happen if you're not going to run out? What's the lowest amount of ice cream that people want to buy and you don't run out of ice cream? Very simple.
1,100?
No, because let's say,
Oh, 1,099?
okay, let's say only one person comes in and wants that wonderful ice cream. Are you going to run out?
No.
That's certainly not over 1,100 ounces.
Got it.
What's the lowest amount of ounces that could happen and you don't run out?
1.
Yeah, well, how about a half an ounce? 0. 0. Yeah, and that could happen. No one comes into your shop.
Right.
That can happen. You don't want it to happen, but it could happen. What's the highest amount?
That's what we want to know.
Exactly. So we leave that one blank. And then hit calculate. So there we go. If you want a 99% chance that you won't run out, then you should stock 1,229 ounces of ice cream. Any questions on that idea? Okay, that's pretty much everything I need to say. So I am going to stop the share or stop the recording.